Is it because I told people that I'm not their father? That they don't want to come and do the course? They wanted me to say, I'm your father, you come and do the course. What are they doing?
It's raining. Maybe at home.
At home? In the hostel? What would you be doing in the hostel campus time, during the time for lectures? It's supposed to be in a library or in a campus.
Everyone takes lunch.
It went after lunch. It started at 4, 3 or something like that.
Yes.
No problem, me, I'm here. You can change the lecture. What do you have on Tuesday after electromagnetism?
On Tuesday after electromagnetism. Yeah, we have one mail.
Oh, is it yesterday when? Is it yesterday or the other day when you had to rush to?
Yeah.
Okay, no problem. And do you have any single early morning on any day? From Monday to Thursday?
On Tuesday.
You have a free period from what time?
8 to 9.
8 to 9, a single.
Yeah.
Yes.
Then we can start from 7 to 9.
It's also possible.
Tuesday from 7 to 9.
Yeah, because I always come early and you also can afford. Then I will have Thursday and Friday free days. I never appear here, whether there is biometric or not. So that we will not have to stay here late in the night like this. Waiting for one lecture from morning to evening is criminal.
This will work Tuesday.
Yeah, if we met Tuesday from 7 to 9, then I go for my breakfast. Then at 10 we meet for electromagnetism. Then you relax with other lectures, I don't care what. Then Wednesday, even the Wednesday when I wanted to see whether we can remove it.
Wednesday, the practical.
The Wednesday morning, that 8 to 9, is very inconveniencing for me. I do it, then I have to go to the seminar, then I have to take breakfast. So that means I have to take breakfast after 10. And then I find the Katogo finished. So I was thinking, if we don't push this one to Tuesday, then we can make a triple today. And then Tuesday we forget about meeting early morning.
A people from this lecture.
Yes, from 16, from 4. Do you have anything from 4 to 5?
Yes, we have psychology.
Down there. All of you or a group?
All of us.
The other bit is psychology.
And this one it is good. The problem is only here. It is on Wednesday.
Wednesday.
After lunch.
Until after lunch they are practicals.
It is where we have a problem with this possibility of yours.
What is the problem?
It is we have a lecture there down and we have a practical.
Methods?
No teaching methods.
Which one?
EDE.
What is EDE?
Not yet attended it, you don't know.
It doesn't have a description.
It has.
Yeah, so what is EDE? Education technology or what?
It's not
Economic development, what?
economic what? It's like economic theories and practice in education.
People are really interesting. So it goes from what time to what time?
EDE.
Yeah.
It starts from 4 to 6.
But we have two sessions. We have a Monday and a Wednesday. So what do you have on Monday?
On Monday also there is EDE, but we had decided here we shall do EDE of Wednesday.
Yes, one group of people can choose Monday and do EDE of Wednesday. Then the other ones can choose the EDE of Monday and do on Wednesday. Simple as that.
For us, no, we are confused.
No, it shouldn't be a problem. I'm still sure that we shall be very few.
Yeah.
So if we are few, then it becomes easier.
This was on the trip.
If you didn't have anything from 16 to 17, we would make it a triple up to 7. And then
make it a triple set that we meet once for this.
Yeah, we meet once, we chop. Think about it. If it works, me, I'm okay. So that when I come today,
the triple idea will work.
I fix it, and then I know the next day I don't have to be confused. Where is the DJ? My DJ, where is he?
It's coming.
What is his name again?
Jansi. Jansi still home.
Jansi is still enjoying his machines.
Life is trouble on Saturday.
So I think now venues are solved. The venue issue is solved. We shall strictly use this place. I'm not going to go to the lecture theatre at any one point. And so you will need the new manual. Sorry, the old manuals, both digital and analog, but there is only one digital experiment that you will be looking for in the whatever. So I will introduce practicals in a practical session, but I want you to know the tentative practicals that I will try to see whether. So we have 1, 2, 3, 4, 5. So we need only 5 weeks to finish them. So we may not rush to start practicals soon. You are still fresh from last semester's practicals, so it's not that you don't know what is going on. So, or maybe we do some projects, you do some stuff. Even before doing the actual project, you design some stuff and then you burn it up here. Yeah, you go on the net, you make a simple transmitter, like a remote by having a transistor here and another LED light there so that you can switch it off or on remotely. And then but that's not. There, the guy who is supposed to switch off power, I think he was drunk or not around. Because it rained, it was thunderstorm, but power was on. Flapped. You don't know that sometimes switches off whenever Kauma,
Yes, please.
why haven't you enrolled? You lost your password. Or you don't have a PC. Because I was actually thinking that this guy maybe came and didn't find things nicely and disappeared. He doesn't want to enroll. But I saw you enrolled on the other one, on electromagnetism. This one you haven't enrolled.
I'm going to enroll.
You are still looking. So the practicals that we may do are D4. Did we do D4? We already did D1, D2, and D14.
Yes.
So we shall do D4, which should be having I think should be a segment. Then we shall do R1, the robot. And this robot is, if you are few, then we can do R1 and R2.
Yes.
Design, even we could have R3 where you decide to design yours and have an activity. So let me take it as R1, R2. This one will be line follower. And then this one will be explorer. Anyone of you taking space? Oh, space was last time.
We are taking it this semester.
How many? Explorer will be relevant. And anyone of you who did astronomy last time? Still the same fellow. So Explorer will be able to show you how, for example, how Curiosity rover is more mimicking this one at the lab level when the other one is a practical game. Then we would have done E15 for understanding voltage regulation, but we did it last semester, much as we didn't figure out what we were doing. So the next one will be E17. I'm frank, I know to beat around the bush. So E17, and then E19, and then E22.
You're really fine.
Huh?
You're really fine.
Yeah, but they have become 6 because of these two. It should have been R1 robots, but I have 2 sets of robots. Because of the numbers, I used to, at one time I had almost 60 students, I think. I mean 50-50 each group almost. So the one robot was, I mean the 2 robots were not able to form 2 practicals. But if we go up to 10 maximum, and one group has 5, another one has 5, that means you can have 2, 3, 2, 3, working on the robot in a given session. So that we call it R1 and R2. So this one will remind us about digital electronics a little bit, mainly with the amplifiers. Then, I will do an introduction to the lab, to the electronics lab session, but I can even figure out here what D4 is about, so that you know what we're talking about. So D4 will be like an extension of the of D14. That is introduction to the operators and uses of flip-flops, operations and the use of flip-flops and the RS, the reset set, the Q and the not Q. You'll be able to, and then the clocks, the edge-triggered JK flip-flops, so that you are able to see what should have been done for the last time. We could have done the D15 analog to digital conversion, whatever, but the apparatus is not available. So, but at least you did D14, and most of you were able to do D14 comfortably. So, then the E's, we have R1, R2, I brought one robot, the other one you can do. So There is NXT1. One of the robots is NXT1. The other one is NXT2. Then you say projects. And then you look for the Explorer. And then the line follow. When you Google this, NXT, they take you to the website for the NXT. And then these robots are called Lego robots. It's a company which makes robots. If you have strong batteries, you can make a full human with all the sensors put. I made it and it only did like this. And then the batteries disappeared. They got done. So when you Google this and you get the NXT instructions, then you, so the reason I'm giving you, I don't know exactly which one has which. One of the NXTs, one of the bricks has Explorer. Okay, both of them have Explorer, but one has a line follower. The other one doesn't have. You don't understand, but you understand when I come. Those robots have bricks. But why am I theoretical? I can go get a whole box, but I didn't want to do that because now we're supposed to be, it is more of the practicals. And probably I would do that when everybody is here so that we don't. But in the meantime, Google. Then we look for projects. And then these projects will give you instructions. And instructions are in form of parts. They make similar parts, line them together. You need 2 tires, you need these many pieces, you need the brick. And then the next step, they show you which one you build first, then how you join it on the other, then finally connect the sensor to port C1, connect this other sensor to port A, and then finally you look for the program, run, and then it starts doing what you want. So the Explorer one is, since you are few and you are all nearby, I can try to show you. I think I should retire and let people watch my videos. So this is the Explorer. You don't need to. So it has sensors. I'm trying to obstruct the ultrasonic sensor, just like how bats work. The bats just send the ultrasonic, then when it comes to dodging, So this one has 2 sensors, the ultrasonic and the touch sensor. The one I came with yesterday has the light sensor only. Because I told them that when I'm not perpendicular, it will not see me, but it will see here. So when I said maybe so here, they laughed. So the programming is that if the obstacle is below the eyes, below the ultrasonic sensor, then it should be now the touch sensor on the bumper. So that bumper is wide enough. So a mature robot, like the one on Mars, if you were to deploy a mature robot, let's say there is a radioactive disaster and you wanted to send the robot, you put on it cameras and you want it to go and show you how place is fairing before you go there, humans go there. So you would want to make sure that when the bumper hits a stone, then the eyes look for where it can go. So in programming, you can now program the distance it should be able to see the obstacle and how it should look for where to go. Then you can see whenever it would touch, it would go behind, look again. The going behind is to give it a chance for the bumper to turn without again knocking the same obstacle. So those are the things you program. Then how speedy should it be? When it is going backwards, should it be quickly? So when you hear programming, whatever, it sounds like it is a complicated thing. No. So this is why I normally complain about you Africa. As you are eating matoke, and I don't know, playing whichever games you are playing, for the kids of the American people, they buy them these robots. As you are playing snakes on phones, these ones are programming robots. As your children in this curriculum are making cakes, their children are programming robots. Then they end up working in NASA. Then you are saying, even if my child drops out of school, at least they can make cakes. I don't know. So this is the Explorer. Let me just look for you the one I brought here yesterday, but when it is on the actual platform. So all these videos were there, because I think these ones I took the videos in 2018 also. 7 years ago, I was doing this stuff. So if you were to do, for example, precision agriculture, in space you can use GPSs, enable them on a tractor, and then the tractor does autonomous activities. For example, it can do spraying when nobody is needed, using the coordinates of the GPS. But also you can, if you have a garden which is very flat and you have your tractor, you can make sure that it goes and follows the line demarcated between grass and plants. And then you make it go spraying. Or you can say it follows that line or ridges, like you have seen when you are, for us when we will be growing potatoes, you make ridges. You don't know how to make good ones, for you make it to this thing like this, and then you put the plants there. For us, we make elongated ones like this. So we keep putting plant here, plant here, plant here, plant here, plant here, plant here. Then the tubers grow in the soil that we put up. But for you, when you do these short ones here, that's why you find the potato is just swelling like this, bent like this, because it tried to go on and stretch, but it couldn't go, so it struggles and you find it is bent. In our place, you will find a potato which is almost this size and straight and smooth, because the soil was free. It grew comfortably. The reason you put this heap of the soil is that when you put the potato plant here, in the tuber, any tuber, any root that tries to go there, it goes comfortably, then swells into a tuber which is big, smooth. Not these ones you find as if they are these muscles of bodybuilders. You find it has patches around. Peeling it is even a problem. Ours, you just get, you wash, you cook like it is, then you start peeling them with the hands. So you can demarcate your garden and make sure that it is well demarcated and make it have a tractor which is like a robot. So that's why I was asking him whether he is a... Yes, please.
So it is what you say the radius.
Yes. You make sure that when the light is, when you are demarcating it, there is a separator. So if there is paspalum here, and then here there are G-nuts, then the line is that line between them. So it can now go across there. And so when you have the spraying nozzles, those nozzles can spray your G-nuts nicely. And this side and this side. So you can have your line being your paspalum, okay, grass. You have grass here, then you have G-nuts here, G-nuts there. So the tractor keeps on this line of the paspalum as it sprays the G-nuts. It reaches there, goes on the other line, comes spraying the other group, and then you find that it is autonomous. Not the way we just eat matoke and we are comfortable without thinking. And then we are now making our children rear chicken, and then we say they are now having something they know. Doesn't make sense. I just want to look for the precision agriculture videos so that you can get a feel. I want you to see this course as a course that makes you be different, rather than a course that you will be struggling to just get an A. Some of you just focus on an A and you have no interest in any comments so far? You are just annoyed that I'm making you start straight away when you are supposed to be enjoying your rooms after coming back. Do you know benching? Have you ever heard of something called benching? A bit.
Yes.
So what did you hear about benching? What is it?
Okay, me what I know
Yes.
is like going to some other place that is very cheap to the one which is staying, and then find out what is taking place there. Then come back, implement, if it is one implementing.
Well, that is benchmarking. I'm talking about benching of campus.
A benching?
You either know or you don't know.
Benching of campus?
bench, there was like official going to visit girls if you are boys, or like Lumumba going to visit the box girls, like when it is like when freshers have just come. You go and visit any room.
No?
Something like that.
I don't
So you need to know it. That's why I'm cutting you short. I've seen. I don't know whether it will open quickly. And then so that tractor is having nobody inside. But it has, the nozzle has a sensor. So when it reaches trees, it will start spraying. And indeed when it reaches trees, you see trees now shaking because of the spraying wind. When it goes off the trees, then the nozzle stops. So that's the reason for sensor. It will spray, reaches where the fruit trees are many, then it starts spraying. Now it is spraying. And you see the trees shaking. There is no person inside. When the house GPS and that, and it is moving autonomously. It is driving itself. So to avoid the effects of the pesticide, then you make it autonomous, it goes and sprays the next time. So this, then I want to look for the one which has precision, like the one I was talking about.
No, wait.
Yes.
Who are the sensors? At the front or?
The sensor is on the tank, on the nozzle. There is a nozzle with a sensor. So when that nozzle reaches an obstacle, which is now the tree to be sprayed, it triggers the nozzle to start releasing the pesticide.
When the GPS antenna is on that.
The antennas are for the navigation, so they are on top here. The Tesla drives themselves. Teslas use a different thing. They have cameras, and then by the way, a car, you can drive a car with 2 fingers like this, from wherever up to wherever you are going. 2 fingers like this. Or you can just hold like this and drive wherever you are going. If you are on a smooth road, where not these potholes will come back. Where you are swinging this way, then swing this way, as if we committed any crime. I just want first, so there is a lot we shall really, I will enjoy this course in a due course. And you, it's up to you to, it's up to you. So I am not interested in advertising a course for anyone. I like now those who are willing to learn. I'm no longer into forcing people. So this is in the lab. This is in the lab. They are now trying to program not program, but to design the sprayer using infrared. So the nozzle is near the infrared sensor. So as it moves, I don't know whether. Okay. As it moves, if the sensor reaches the fresh parts of the plant, then it releases the pesticides. Reason, any pesticide infested plant, the pests would be where they are fresh parts of the plant. That's the rationale behind. So it moves when the pesticide, when the sensor sees fresh I don't know how is it shoots or whatever they call them, or leaves. But these ones which are sprouting out, they are not just leaves, they are just coming out fresh. The buds. So that's where the pests want to go, and that's where you need to spray. So you program the infrared that when you see this immensity of the green, of this budding, whatever, then you release the. So the reason we call it precision agriculture is that we don't waste any pesticide. We use pesticide where we need it. When the tractor was in the trees, it does not go spraying everywhere. So I'm looking for the actual video which really demonstrates the precision, whereby it can spray and the nozzles chop off at the line. Then wait for until when it reaches the other line of the other plants, sprays again. And if you were the one doing the pumping, by the time you remember I've reached a line, you have already sprayed almost halfway. Then by the time you remember you're supposed to be starting to spray, you have missed a couple of plants. So there's no precision. But all in all here, what I'm trying to do is to show you the sensors, the application of sensors in these technologies. Yeah, this is a spray, which has those huge arms here with nozzles which are sprayed. So there will be a separator of gardens. Normally you need to separate your gardens to avoid the crossing of pests. So you can put a separator either plant. So if you add maize here and you have a separator, then beans, pests do not easily move across. When they get lost in the grass, they don't want to continue in grass where they are not eating. So they may be isolated this way, and then your garden the other side survives. Has the man come with holding the things in the hands?
Yes.
And by the time he remembers to lift them up, not to spray, then by the time he remembers to spray again, he has already crossed. But you see how nozzles switch off immediately they reach a line. So that's the application of sensors. And so the main reason for you it applies to this, because if you learn about space weather, then you'll be able to know how the space weather affects GPS. And if GPS is being applied in such applications, then you need to know why you should know those effects. To help people who are using GPS like for this purpose, for navigation in the aviation industry, for that is airplanes, when they are landing, taking off, flying, they are tracked using the GPS. GPS is being used in surveying, etc. So knowing about the effects of space weather and how they are affecting the GPS, then you know that how it will affect the applications. Mobile phones use GPS. ATMs use GPS. Rescue services like ambulances and the like, they use GPS. Anything that affects GPS affects our life. So now you know why I'm teaching you the sensors. When we go to the communication system, then you understand, then you know how radio works, how a simple circuit can be built up, and then you are able to make the transmission and of course communicate. So there is the one which I need, the last one to show you. There is a mower, and this mower kind of competition will help you to see. So this is a competition of university students designing mowing machines, from planning time, finding out how they should make it, to implementing it, as yours here are making cakes.
What we found over the last 5 years is the competition has enabled students to get together, work as teams.
So they are supposed to make a mowing machine which goes in the compound, identifies the obstacles. If there are cats and dogs, it shouldn't cut them, should be able to dodge them. So kids are given a chance to plan, brainstorm, find out how it should look like. So for you, as you are making dough or making the cake, I'm not happy. But those people who hear me complaining, they don't know I know all this stuff. But I have all this stuff that is being done by other people, and people don't do it. So this video shows you how these kids sit down, plan, brainstorm, argue, say no, we gotta make it look like this, we should remove this part. Then someone says they get some teddy bears to act as dogs and cats, how it will be done, how it just moves with it and knocks it through without dodging it. But I think we are who we are because of you have no problems, you do not innovate. But when you have problems, I think you innovate.
We get students out there using the equipment, interfacing with it, it really gives them an opportunity as they come out to the workforce, ready to go. They actually have some hands-on experience. They know how that classroom applies, the classroom work applies.
The benefit to a student to get involved in this competition is the opportunity to actually work with real equipment that is in production or they may even design that's trying to solve the problem we face today. Now, give an example of how it works. The technology that we use by itself could be used
is one of our cleaners,
for driving a tractor,
now a lady.
She
will be cleaning
near
the door with the wet thing, and it's the one which will wet all doors like that, and that's why they need like
a
that.
lot of companies are looking for that hands-on experience. So if they
That
get undergraduate students that participate in
part
this
is because of passing
know
there
the
and
issues
wet
with building for a lot of
more.
people. It's like a little vertical gold mine. They get somebody they can hire that
all doors, because by that time she was like the only thing around. And they are all looking like that. So these are students making a mowing machine, but then there is a DARPA competition by companies which made actual vehicles which were being controlled remotely. And so I want to show you that, then we try to finish the course outline, and then I let you decide. So this is a competition of mature vehicles, mature robots, which are autonomous, mature robots, which are vehicles, which are autonomous. Nobody is inside. The control station, people are remotely controlling them, and then they are able to drive, reach a turning point and turn very nicely, turn precisely, nicely in a way. And but this is when somebody is controlling them with the computer. Elon Musk programmed or took a video of the roads and then integrated them in the software. So a Tesla will drive, will know here I'm supposed to turn to the left. And then it turns to the left. it speeds the way it wants. So you just say, I want to go to Kororo. You just, the vehicle starts itself, you sit behind. It reaches the main gate, it stops for opening, they open for it. It goes to one gear, the lights are there, it goes in the lane for lights. I have cried for KCCA. If you don't want to put lines in the road, at least towards the lights, put those lines. You find vehicles almost facing each other at near the traffic because a taxi is you have stopped on the line like this. Taxi wants to be in front of you, then reaches and puts in front of you like this. Another one comes also puts in front of you like this, just because they want to be in front. So that competition is for the mature robots, which are the autonomous vehicles. So Tesla has autonomous vehicles, and there are other companies also which have made autonomous vehicles. So I think is it in 2021 or 2022 maybe, I wrote to Elon Musk on Twitter that send me a vehicle I tested in Kampala, and then some of my students who were accessing my stuff on Twitter laughed at me. But I was doing it for some purpose. I was doing it to see people's opinion. But why not? If he sends me a Tesla and I try it on the northern bypass and the expressway, I'll be. But in Kampala, it cannot drive itself. With these fools, these taxi people. They will just knock it. They will just knock it. But it dodges vehicles. It is very intelligent. But I will buy it. I will buy one and drive it. $50K is not so much. I can sell for that. How many years are those? $50K. $1,000 is 3 million. Almost 4 million. Then you multiply by 50. That's about 150 million. I can manage that. Huh? These fools in government drive 600 million vehicles, V8s. So 150 I can get a loan and drive a Tesla. I can get a vehicle loan and drive a Tesla around town. Someone was bragging to me that I can't drive an automatic vehicle. I want to feel I'm doing something. I said, you are a fool. I earn money, then I start struggling on the road. I'm busy with this. Then the vehicles, you are stepping here. I just need to relax. Need to drive, just even hold my head. That's why I went to school. I didn't go to school to show off that I am engaged in 1, 2, no. How? I went to school to relax, to have peace, not to suffer. That's my analogy. So at least I have showed you also I wanted you to understand that when I'm complaining that people are teaching our children things of people who shouldn't have gone to school, you can't tell me that because now kids are making their own cakes at school that that's an achievement. When will they know the theories in medical? Those complicated things in medical which they should have understood when you are just making them do what villagers do better. My mother never went to school, but if I tell you how whether it is beans or maize or sorghum, she knew how to plant it, and the yield is good and no complaint. And I'm a farmer these days. I go to the garden. These are my hands. This one I put on a glove. I have videos. If you are thinking.
That's a big video camera.
Yes, I dig with my camera. I dig with my camera. of gadgets? What do you mean by misuse of gadgets? My garden is very clean, my friend. It is not, it is not a dirty place. It is a green place. My garden is a clean place. It is not a dirty place.
It's a demonstration garden.
I want to make it that. Because me, I don't throw away garbage. I bury it in my garden, it becomes manure. I don't know what these fools do, who take things in each days. Garbage should be separated at source. You're supposed to be having they call them containers. You're supposed to be in the movies, you see them. Even here, there are some people with them. They have wheels here, cover here, so you should have a green one for biodegradable, yellow one, for example, for recyclable like paper. Then you have a red one for like bottles, glass bottles. You can have a blue one, for example, for metals. You can have another one for plastics, for kavera. For bottles, we had what they call reverse recycling. So when you buy juice and you have an empty, or mineral water and you have an empty bottle, you take it back to the supermarket. You dump it in a machine. The machine processes for you a receipt. You can use that receipt on the counter to pay for things, or you ask for cash. The Ghanaians and Nigerians would fight for the bottles, picking them anywhere. So you wouldn't find any bottle thrown anywhere. For us in our flat, you buy juice. When it is done, you put the bottle on top of the fridge. When you are going to do shopping, you put in kavera, you go get your money. That's what I wanted to. If I say that I buy one and bring it here, some fool will bring like, fill up all the supermarkets and then makes you broke. That's my problem with Africa. But when the soda, if it was 500, you can add on 100, become 600. Then they reimburse, the machine reimburses like 50 shillings. Then the other 50 shillings goes for the service provided by the supermarket. And you will not find a single bottle in Kampala. And it wouldn't even be dirty for these street kids to pick them, because even the ones who take in a can, they are like squashing and throwing in the window. They will be putting them somewhere safe because there is money in a supermarket. But I don't know where the problem is. And what annoys me is that, for example, in this department, almost all of us stayed in Norway for more than a year. At least at this point, most of us did that. If not Norway, Germany. If not Germany, South Africa. But when we come back, we go to default. We go back to the village level. We default. It's like we have switched on troubleshoot to the village level. When I'm busy carrying a camera to take videos, carrying a laptop to explain things, when I'm buying a telescope to show people the moon to inspire them, it's like I'm crazy. How many practicals did you do in other courses?
1 to 2 hours.
Now, when me who gave 10, were they 10? I'm crazy. I'm confused. I'm making students suffer. That's why your friends have not come. They think we are going to do like 20. So they are like, I suffered in electronics, I don't want to go back. But you regret when you reach the school, or when you get a good class and you are supposed to be a lecturer, and you have no idea where to begin from. But you studied. Then that's when you say, oh, BFT was doing his work. At least I know something in electronics. I saw this, I tried this. The one you thought eased your life actually complicated your future. I also need life to relax. By now I'm home. Even if you see me in the office, I'm home and in a home environment. If it is before 8 a.m., I'm home. I'm home, I'm in my sitting room watching TV. But I came early to avoid the jam. When I leave home at 5, I drive like a king through town. And then I come and go back home here in my office. If I leave home at 7 just because, or at 8 or at 9 because I wanted first see morning breeze or first relax a bit, I reach here when I'm exhausted, annoyed. Border was going this way, this one is abusing me. The taxi is saying, Tomani Kubuga. Yeah. So you reach here when you are exhausted. But me who comes early, I am at peace. Even the few people I find on the road, they are also hustling. You can't find someone hooting, that fool who hooted at me, whom I said they hooted at me, but at least you are sure that he also had problems at home, but at least he's also rushing to go to work. Or do whatever he's doing. After all, at 5, some people are from the club. It's not that all of you are going to work, so you have to be careful. If he's slow, it means he's coming from club, he's going home, he's trying to be. If he's rushing, you are all going to work, for whatever reason. Then there are those who I didn't understand whether they wanted to go to work, but they are not sure whether they are going to work because they don't want to cook. I was about to forget you registering. So I want to finish the outline, and then we should be able to. The course it doesn't have to have not a lot of equations or whatever. It's basically about how I would want you to know how you can use a given sensor to do something. For example, I hinted on an idea when we were either doing instant magnetism or electronics. We shall look at the sensor. If I have a capacitor, for example, and the dielectric, there is a dielectric here, and the other plate down here. You know inside here, this door here, has this part here for the locking. So if this was to be a dielectric, and then the other one on the wall, on the other side of the frame, is the constitutes the plates, then I can activate the plates there with the current, so that when this dielectric goes in, it changes the capacitance. So then I can make sure that I integrate that with a small circuit, with a buzzer, and it acts as an alarm. So if you come and I locked the door with a key, the dielectric went between the plates. So if I program my buzzer, okay, my alarm system, that when you come and remove the dielectric without deactivating the buzzer, then it makes noise. And you use the theory of the capacitance to make a complicated alarm system, which is simple. So for me, who is the owner of the door, I know I have to first switch off the alarm, then open the door. You a burglar, you come, you have either stolen my keys, or you have made another key, you come, or you want to cut, or whichever, then you struggle, then alarm goes off. And the door looks like nothing nothing extra is installed on it. So you can make locks which are embedded with an alarm system, and then you sell it to people. You say, we shall install for you the lock. It will be using low power from your mains, but low power which we shall integrate in your whatever, and then no one will even feel there is an alarm on your door. Africans don't want to do it. They want to be beggars. All the time making projects to beg for money. Project after project, project after. You will never develop, I'm very sure. If you develop, you can shame me and develop, but I will be having gray hair and no longer care. Because you are comfortable begging than using an effort to do amazing stuff. You are better off, okay, you find it easier to write a project, so how you will implement it, than actually going down and doing the actual stuff and make yourself better. What I'm looking for is in the other. So we met yesterday at 8. I just want to make sure I select your one. Who is not here today and was Farasida? Did she opt out or she's in? And where is Luko? She just enrolled and doesn't want to show up. Sick from what? I've not been sick of malaria since 24. So on the 4th of August, I celebrated 20 years since. No, on the 7th of July, 7 July 2004. This is the last time I was diagnosed with malaria and got treatment.
You suffered for over 7 years.
Then on 4th of August, now I can brag because I'm not going to get malaria before that rain. On the 4th of August 2024, then I traveled abroad. Since then, I've never gotten malaria. Of recent, mosquitoes have been very annoyed with me. So now I have put under my table, I put the reading lamp. So the light there has chased them. They come up here to look for me, then I smack. And I told you, I watch TV in a net. So even in the sitting room now, I have become like another professor. I have a net with my table inside there. I have the photos. So I just go in, put the net, and work. I work, I am looking at the gate when I'm seated on my table in the net.
How about in the laboratory?
When I'm in the laboratory, I'm very active. I don't allow them to touch me, but they zoom, I hear them zooming. And I keep hitting myself until when I'm done. No chance at all. I don't know how you guys take my words. I have not taken any tablets since 2004 for malaria. Before, I actually thought I had HIV because every 3 months I would be down. I had reached an extent of now going to the hospital. They plug in here the cannula. I stay there with putting quinine in the body for the whole night. In the morning I go back home when I have the dose. That's the extent I had reached. But when I was going abroad, I went to Ebenezer, they tested me, they gave me a consultant, we chat. He said, no, when you go abroad, you will never get malaria. Don't worry. We are going to give, on this date here, we are going to give you all the medication, the full dose, you will never get malaria again. When I spent 2 years in Norway without getting malaria, I said, that animal called a mosquito will never meet me anywhere. If I hear it when I'm in the bedroom, I will hunt it until when it is dead. That's when I sleep. No spraying. I don't spray anything. I make sure I smack it and be sure it is dead. Then there are fools who say, but the net is so hot. When I go in the net, I feel sweaty. Then don't cover yourself. We cover ourselves to be warm. or some things like mosquitoes not to eat us. You are already in a net. So why do you cover yourself? Just put on a bed sheet and that's it. So that's how I take life. I don't know how other people take it. I no longer follow the norms. I follow what works for me.
You're creating your own happiness.
Eh?
You're creating your own happiness.
Yes, if you don't create your happiness, you will die in misery. So I've chosen to live my life. And that's why I want to retire early, maybe build a small demonstration school. I get when the children break for holiday, they come to my school sort of. We do all experiments in medical, all experiments in Abbott. I take them through experiments, I show them how results are made, their parents pay, I become rich. These things of telling me the timetable is out, I would have survived. Because the other side are my own what? My own boss. And then I go, when the kids are not there, I go to the garden and, plant fresh food. No pests, no pesticides, no fertilizers. Natural. Okay, let's finish the outline. We had done mechanical detectors, the strain and piezo, and then I had started on the capacity transducers. So it was number what? Here they are not numbered in the book. Number 5. So I was supposed to start on number 5. Or number 1, 2, 3.
Number 5 is capacity.
Yes, that's where I am going now. Capacity. Transducers. The reason I repeat them here on board is to make sure that I can add some meat on the skeleton, much as these are already on where for your access. So capacitive displacement transducer, there is a capacitive displacement transducer, which I have just explained here when I was explaining that movement. If you were to displace a dielectric in between the plates, if we have these plates here, and then in between these plates we have a dielectric which we can move in and out in between these plates. So if we can have this sliding in and out, if it is fully in here, in between, it's a particular capacitance. When you drag it out, then you have this space being a free space capacitor with free space. This portion of the capacitor will be with the dielectric. So the capacitance will be changed. And that means if you translate the capacitance into a voltage that's be seen as a signal, or making a buzzer go on, or a given value to be given, then it can act as a sensor. That when you pulled out the thing, then it made this noise. So for example, I don't know exactly how it works, but my smoker is installed with sensors on the tires. When the tire thread, the pressure goes down, they light. The tire thread symbol in the car lights. So you know one of my tires is what? Is having low pressure. So you can go and hit on them and know which one. When I just pulled that car, it happened, I was confused. Then I went on the net, I found out it is the tire. So I drove to the gas station and told the guy, you check for me the other tire. The pressure is down. He said, but how did you know? I said, it has a light. Because it's like a computer. Only that when these fools now started working on it, when they were checking shock absorbers, now they broke the wires for the sensor. And for them it is not a problem. So recent, my cooling system, the thermostat got broken. There is a pipe which gets water from the engine. It had broken. So when I almost got stuck on the road, but then put more water, reached home. Then I looked for the problem. I got it. I removed the thermostat. I brought it here. Called my mechanic to get me the thermostat. And he was looking at me as if, how did you get this? I told him, yes, I went in the vehicle and looked for the problem. Soon I will not be looking for a mechanic for what? Just fix my thing, those which are fixable. Not maybe these things of shock absorber where you have to struggle. But Bazungu work on their own thing. In my flat, there was an adjacent flats for citizens. One guy would get out his Benz, rip it off, like open the engine, remove a few things, washes it, sprays it, polishes it, puts it back, and you'll see a happy man who is working on his vehicle. If you have a vehicle and you are washing it yourself, let's say every morning or whatever, once in a week, how do you subscribe to the gym and then you have a compound at home to clean, you have a vehicle to wash, but you are taking money to the gym people when you can do gym here and when you are benefiting yourself? Before you guys came, we had a fence, a nice fence around. So I one time got a guy and said, there's a guy who was cutting it, he cut it wrongly. I talked to him, he didn't care. You see, some people when they see us, they think for us we do in the book, so we don't know any casual work. So I chased him. So I got another young man who said he could cut it. I said, how much? He said, 100K. I said, hey, 100K. So I made a check for myself. Then I would come on a Saturday in a truck shoot with my cutting thing and chop it. Then put cameras to scare away people. You see, when people know you and they know you are their lecturer, you are a lecturer here and you are cutting the fence, they want to take photos, but they will see me with cameras filming myself. So I would disarm them. Then I would pay myself 100K. Come on a Saturday, cut the whole fence, I pay myself 100K. Which job do you do when you pay yourself 100? And that full thought I could say, you come for 100. To cut a fence from here, just here. I'm not saying that you become mean, but Bazungu don't, you see them donating to us money, but they are mean. The man will work for a whole year without spending so much money, then he saves everything, comes here as a tourist. And then people think that tourists will be giving out free money. That's why they are mean. You take him on a motorboat, he asks how much, he gives you exactly that. You don't see them giving out money like these other, is it what, Brian White? I don't know where they used to get the money. So the displacement is this one here, and this one of the direction. And then the other one is variable separation. So this is displacement transducer. Then we have variable separation. Variable separation. So if you, for example, wanted to detect people, you can make this walkway, or in here you can make the floor to have the act as like two plates. So that when you step there, the separation reduces. So then the capacitance reduces. So it becomes a signal to the whatever sensor you have put, okay, to whatever detector you have put. So for example, if you wanted to know if people have passed your front door, you can put some sensor like a capacitor in between the rack and the ground, so that when somebody comes and steps on your doorstep, the capacitance changes. Variable separation, and then makes an alarm, for example. If you wanted to know people who are coming to check on you, or those who are coming, when someone is on your door, is peeping to see whether you people are there, then the alarm goes, and he's like, he's wondering where it got triggered from. Then we have the area and dielectric of the parallel plate capacitor. You can have this area changing if you had like a retractable plate. You can have the separation here, distance of separation changing. So the other one is area and dielectric. So dielectric is there. So area and dielectric. Area and dielectric of a parallel plate. You have a lecture or what? I hear you. Parallel plate capacitor. So you can have the dielectric changing, and then it becomes a trigger for your signal to give you, to act as a transducer, to be able to give you an output, or to act as an input in your. So then the or cylindrical capacitor or cylindrical capacitor. So the car fuel gauge has a cylindrical capacitor somewhere in the system. This cylindrical capacitor here. This is the cylinder, and then this is the inside cylinder, and then you have the fuel in between here. This is cylinder 1, or like plate 1, this is plate, cylinder 2. And then when you put the fuel in here, when the fuel fills up here, it changes the capacitance. So when they are filling the tank, this fuel going in here is depicted on the gauge and shows you how much it is. That's why the gauge of the vehicle cannot tell you these are the many liters, because it cannot be as accurate as that. But at least it can give you a chance to realize that it is halfway, it is almost full. It's non-linear when you see the calibration. I don't know whether there are digital ones which can tell you exactly the liters you have. I would wish to know a car that tells you exact, but they will just tell, it shows you the gauge just where, how far you are. And this is the cylindrical capacitor that is used. Because of the change of this capacitance. If it is full, then you have the maximum capacitance, and then that shows you at the full. When it is empty, then normally when you are remaining with about 5 liters, then it shows, it starts lighting. So now it goes to the extent of giving you a red light. Then when you shake the vehicle like this, then it disappears. Until when, so sometimes when I'm broke, when I shake it, and the light persists, then I know I'm in trouble. I am only having 5 liters to reach home. But most times I am always on a full tank. I make sure that the car is full tank. These things of putting 20k, and then before you move from here to there, it is already red again. It stresses you up. You live a stressful life for nothing. So this is how capacitors can act as transducers. You can have the displacement, that one, directly going in and out. You can have variable separation, like a weighing bridge. The vehicles just come, drive over a bridge, and then after driving there, then the kilogram, the weight is shown there, tonnage, and then they say, no, this is overloaded by this because of that separation depicted as whatever. The area, you can change the area if for example, I have these sliding windows and they were to be acting as plates. And when you slide the window open, it is now showing that you have reduced the area. then you can say when somebody comes and opens the window, when you are unaware, then it should make an alarm. Or you can say when you open the window, then the signal can go and switch off AC, because now you are getting fresh air from outside, and you wouldn't want to overwork the AC trying to blow and freshen the air when it is strictly going out. When we are implementing AC in a room, you first have to close the windows so that you are dealing with removing the air here as the fan from the system of the AC is bringing in more air, fresh air. If you have a car and you open windows and you put AC, you are wasting your time. Because you are trying to make sure there is circulation, but this air is coming in hot, and you are doing so. You have to seal off the glasses and make sure that whatever is circulating in here is strictly coming from the input, and the one which is in is going out, so that you have good temperature regulation within the cabin of the vehicle. And then the dielectric, the same as like the one of how you, when you are displacing in and out, or if you can change the dielectric automatically so that it now gets depicted that something has changed. And then for cylindrical capacitor is when you use, for example, the case of the fuel gauge which I have talked about. Then 6, inductor. We talk of the inductive transducers. So if you, for example, in a tuning circuit of a radio, when you change the size of the coil, you hear the radio kind of tuning itself. You hear it changing the channel because you are now interfering with the windings. So that the windings can help out and be able to be interpreted. So inductive transducers, and under this we shall look at the magnetic circuit. Magnetic circuit. We look at the simple examples. The simple examples of the magnetic circuit. We got the variable reluctance, displacement transducers. My eyes are variable reluctance transducers. Even a simple transformer is a sensor. You put in AC here, it causes a magnetic field which is changing, then it affects the secondary, which gets induced with the. There is no connection between the primary and the secondary. No connection, no electrical connection. It's magnetic. It's a magnetic circuit relating to each other. And then the secondary will get the induced current. That current flows. Then you can either use it directly or first rectify it. But most times, most of our circuits are more functional with the DC. Even when you are drawing the AC straight from the socket here, the circuit inside makes it direct. And then that's when it is usable in most of our electronic circuits. Because of the nature of the laws that we have, Kirchhoff's, you don't have Kirchhoff's going this way and this way. It has to flow in a particular flow. And then you can find out more about this. Then 7, we look at the block diagram of a communication system. Block diagram of a basic communication system. Over an analog one. System of, I think this outline is a bit rugged, but this we can have an analog and a digital one. So these days we have analog and analog. I don't know which one is American, which one is British. There is analog which is like this. Analog like that, then there is analog which is like this. Which one is British, which one is American? I have no idea. Got no idea, I can see it in your faces. So then we have analog modulation and modulation. So this is digital, so it should be, we shall be able to look at analog and digital, but previously it was always analog. Digital came in 2015, that's why we started talking of digital. Digital TV, digital radio, that now you can be on DSTV and look for a channel and listen to FM 9 Radio 1, or Impact FM, or I don't know whether Kabozi is there. So please, Kabozi is a counterpart, it is a Luganda variant, no, a Luganda counterpart of Radio 1. So, I don't know why you are laughing when I say that I was.
It is still there. It is still there.
No, it is there at the station, but I don't know whether it is also on DSTV. But Radio 1 is on DSTV. Radio 1, Impact FM. Then there is some other radio, Alpha, I think Alpha something. Even on free to air, when you search for them, they pop up. So you can be on TV, then you listen to radio.
But they don't.
They work. They are clear.
They have a dollar sign.
No. There is the radio 9.0. The radio 1 has no dollar sign or key. There are those which have dollar sign and key, but you know that is when you are on these stupid, for example, Star Times, which when you subscribe and then you find out, I don't know, but on a free to air, when you get a digital TV, a LED TV with a DTV, with a built-in decoder, they show up and they play. But you know it is funny that you are having a TV, you are listening radio on a TV which you are supposed to be watching. And so, I don't know. So then we look at the, sorry, I think there is something I mixed up. There is block diagram of a basic, I don't think I needed to put a basic, communication system. Then the one which I was complaining about is because I was not reading properly, is advantages of a digital communication, advantages of a digital communication system. System over an analog one. I'm sure you really know this very well. And then next would be analog modulation and modulation. Analog modulation. We don't need to, we modulate analog because they have varying values. And these values we need to kind of keep reducing them or increasing them. That is the idea of modulation or demodulation. So advantages, it's like when we are doing digital electronics and analog electronics, we use are you now able to see we talked of the repeatability, manipulation, cheapness. The other one is what? Flexibility, those things. So if you are having a digital signal, for example, say like TV now, you don't have to hustle looking for a signal. You just put in a small antenna and the signal is very clear. So you don't have to put a big pole and put the antenna there, no? That's why, that's how it is. And then it is clear. You may not have been conversant with those signals of analog. Yes.
Of recent, I've seen these indoor antennas. I don't know if you've seen that.
What do you mean by nano?
The indoor antennas, like free to air, but indoor antennas, something they cover box, they fix it inside the building.
But my antenna here is inside. The one in my office is a normal antenna, but lying on the box, on my cupboard up there, and I'm having full signal. At home, my neighbors don't believe I watch TV because my antenna is inside. So that is just people. An antenna is supposed to be receiving the signal, whether in nano or outside. So there's nothing like in nano antenna or outside antenna. An antenna is supposed to be getting the signal from wherever the transmitter is coming from. I don't know whether I make any sense. But of course, with Kampala people, they will bring anything.
It's this
size.
Yes, they fix it on a wall, and then the wire, then they connect it to that.
It's just people who want to eat your money. The issue is to get signals. If you put it in the basement where there is concrete, they won't get any signal. But even if you got those old, these two, they used to call them satellite antennas, these two, and you just, even if you retracted them in and put them somewhere and put in the TV, it will work. These days the signal is everywhere. Just even if you put a wire in there, some wires, it will work. The signal is everywhere these days. So that's just eating your money for free. But it is an indoor antenna. These days free-to-air signal is everywhere. It's abundant. So I want to look for the system so that you see how it looks like. The communication system, so that you are able to get a feel. So we normally will have, as it loads, we always have information. So the TV people have collected the news, they want to transmit the news. So this you must have information that you want to transmit, communicate. So somebody stood on the camera explaining something, which is landfill, is a dangerous place, we still have many people who are buried there. Then after that, it is fed in input transducer. into the microphone. After it is put in the microphone and of course in the lens, then it has to be processed. It has to be decoded to be able to be transported on media. So it can be through to the satellite, can be through just transmission using long distance communication. So that's another step. But I want to get the actual blocks so that I don't have to stress my head. That's why I came with a laptop. So we have an information source, which so that is like a person we are interviewing. Then we have an input transducer. Input transducer. So could be the camera, could be the microphone. Then once you have gotten this one, the microphone goes in. So if somebody has the news, reading the news, and is having the speaker, the microphone in the radio station or in the TV studio, then now the information gets transmitted. So you have the transmitter. And then when it is transmitted, the transmitter now will send it to a particular channel. So most likely it is going to be wireless, going through the air. So it doesn't matter, it could be the channel, could be wires. If those days of telephone, cable telephone, you will be able to have your information. There is the microphone of the phone becomes the input transducer, the wires. Have you ever seen telephone wires? No, telephone wires on the pole like electricity.
Yes.
They are all spoiled. They used to be like bottles. You will see as if they are bottles on top of. I remember when I was young, where my mom was born, we would walk on foot to go to visit. And along that path going there, I think there is a rich man somewhere near them who had the telephone. So those telephone wires, but also going through town, you will see they are like, but me, I used to think they have gotten bottles and put them on top of the croissant. Then for me, because I had seen these wires, they would be asking why those wires are always, during the day, when it is hot, they would be sagging, like loose. Then when it is rainy or very early in the morning, they are tight, because they were made of copper for good conductivity. And copper would expand during the day, and then it would be tight during the night or when it is cold, because of the expansion and contraction. So the transmitter will send to the channel, and the channel can be anything. But these days we are basically wireless. So the channel will be either free air, free space, will be wiring or whatever. And then when it reaches, if it was like a TV signal from MTV studios, then we would need to have an output transducer. Then that means you'll be having the TV to see your transmitted signal. If it is radio, then you need a radio receiver to receive what you want, and then you can get your information in original form. Finally, so you get information. The way people are in the studio talking, what they are talking, you get it here. And whatever they are talking is what you are listening at this other point. Here, during transmission, we can have some noise added. Some interference can be added, not here, during the channel, not on the transmitter. Here, we can have some noise interference. So that is a typical communication system The information can be picture, sound can be picture, speech, or data. Between the input transducer and the transmitter, the information would have been transformed into an electrical form. You were speaking into the speaker in the radio, now radio station, now it has become electronic. It is electrical. It is now going in that form. It is no longer what you are making noise about. But here between you and the speaker, you are having some analog signal, busy vibrating the air to affect the diaphragm of the microphone. Then that gets converted into signal. So these are on way, but I'm still hiding them to make sure that you come and attend. So this is the block diagram of the basic communication system. And then, of course, the bit of the advantages and disadvantages, then seven or eight. Eight is the radio receiver block diagram. Radio receiver. So we have a block diagram for AM, block diagram for amplitude modulation, and FM and frequency modulation. You can either modulate the amplitude or the frequency. You can modulate the frequency or the amplitude. And this is the block diagram for AM and FM heterodyne receivers. Heterodyne receivers. And I made a simple radio from a microphone. So they are FM microphones. When we talk, then they send the signal directly to the public address system. So I got that microphone, removed the microphone, and put the wires on the output of the cassette. So I would play music on the cassette, and I would receive it on the radio. So I would leave my cassette playing in the room, and I would go out in the compound at Kote, now in Subiwa. I would be in the compound with my small radio, listening to the music that is being played by the radio cassette in my room. That's how sophisticated I was when I was a student. I had a microphone, which is an FM microphone. There are these FM microphones, which when you switch on, then you adjust the public address system to receive the signal from this microphone. That's how public address systems work. There's a channel. You have a channel on the public address system that receives the signal from the microphone, which is wireless. So what I did, instead of having the microphone talking, I fed in the signal from the radio cassette. But then to remain the wireless signal, it remained a wireless microphone that now I can receive on my small FM radio. So I would leave my cassette playing in the room, I go in the compound, listening on a radio of the music which I left playing in my room. My preferred music, not this one of FM, which they put anything they want when I don't want to listen to it, yes.
So what you mean, you turned an output transducer into an input transducer?
It was still input, because the microphone would input the voice from analog person talking. Now I bypassed the microphone and fed in a signal directly, constant signal from the radio. The output of the radio the wires which would have gone to the speaker, I made them go to where the microphone would be feeding. And then now the signal, instead of talking in the microphone, now directly the signal was coming from the cassette. And then I would be receiving that signal on mic radio comfortably. So this radio, now at this level, you should be able to, we shall, those big things, black things, I want them to work during this course and be able to use them. Because we bought them a lot of money, but they have never been put into practice. So I want to make sure that they work. The fewer you work, the better, so that I can make them work out. This time I'm very tough on it. I will make sure that something works. So then, examples of measuring instruments, 9. Examples of measuring instruments. Then the examples, we take a multimeter, and a CRO, cathode ray oscilloscope. Then 10, we look at the examples of refrigerators. Examples of refrigerators. And these refrigerators, we can talk of thermostats, like the one I've told you about, which I'm going to, I think I'll fix it in the weekend, because now I come late, earlier, I leave late. I don't even know how my compound looks like. And then we have automatic switching. You can use a relay to have automatic switching where you have to. I live here late, I come early, so I don't know how my compound looks like until Saturday.
But the kids know.
They would have seen it for me. I said I don't know how my compound looks like. So the kids will see and what? The more you show me how it looks like, what kind of video is that? Automatic switching. Automatic switching, then remote control. We shall see how a remote control of the TV, of the car works like. Remote control. So this is our course outline. And so this course will be handled using laboratory work and tutorials. This is an academic statement. And then several laboratory exercises related to the theory will be conducted. I've already demonstrated to you about the robot. The course will be generally conducted in lectures, tutorials, and sessions. The textbooks are here, but there's a textbook which I have. The mathematical methods in physics is already on web by Boaz, Cooper, the electronic instrumentation and measurement. You can try to search online. The principles of instrumentation, you can also try to look online. There is one book, Prox, J and Saleh, Communication System Engineering Printers. There is a soft copy, it is on web. So the number 2 and the number 3 are on web. Then the principles of measurement systems, Longman, I will look for the other ones to see whether you can get soft copy on web. And now we have almost rolled through the course. You know what each part of the course concerns. So even if you were now if you were to go on Google and start looking for information, you can learn on your own and even get everything on your fingertips. If you stop this nonsense of always waiting for the lecturer to be the one to tell you what to do, you can go now and start designing a radio receiver and implement it. Come here, solder it, make it, then it transmits, you start receiving, you are comfortable, you have your radio transmitter. Instead of waiting for what I will do. If I've told you, I've showed you about robots, you can go to, I don't know whether those guys are still in Tina. They are called the Fundi boards. That young man, he just dropped out of school and decided to start robots. The time I have spent in school and even teaching you, if I were just to start on something like making some small instruments using simple physics, I would be rich enough. But I'm here wasting time coming here shouting at you, telling you come for practicals. So I don't have time to think. That's why people like Zuckerberg, he left Harvard and started Facebook. He's a billionaire. Bill Gates did not finish his degree. He's a billionaire with Microsoft. People who have dreams and chase them. Elon Musk finished his undergraduate, I think did either master's. He had started on a PhD, he dropped it. He's now an owner of Tesla, SpaceX, and X now, former Twitter. He's the richest man. But the other day he was on an interview and he was saying that he sleeps on a couch in one of the production lines of his factory. But for you, you want to sleep in a good bed when you have nothing. Instead of living a good life. Instead of having a good life. Yeah, but you see, you have to maintain a good life. You can't, that good life, you cannot maintain it if you are not working. It will just disappear in a minute. So you have to is it called Fujirira? In Uganda, you have to continue. They say what? Asiko Lamta Samko. You have to continue making sure that Kaumawa is nothing. Because I know the sayings. You have to make sure that you maintain the status quo. Otherwise, when you relax, everything goes. Yeah. Yes. So this is the course. This is what we shall go through. I look forward to have fun in this course. I look forward to working with you where when you know a few things, I shouldn't waste time that I'm loading you with notes. But the course is complete on Wele. The videos of previous lectures are there. There are materials everywhere. The only challenge is that we have transformed, we have transited from analog to digital. So there has to be that transformation. That you can be in books. Most of these reference books will be having those analog demodulation using Fourier transforms. But now we have moved away from there. Simple. You just get your TV, scan through, all channels come from the satellite. I don't need to know how a transponder of a satellite works for me to get TV. I don't care. So, enjoy your evening. And Kauma, you came late. You and Margaret, I think Margaret was here. It is Kauma who came late and we were trying to see whether we could make today a triple.
To be a triple? Up to 8.
No, from 4.
Up to 7.
Up to 7. Then we drop off the Wednesday morning.
It's okay, but you'll be arriving a bit late.
No problem, then I will be leaving late.
No, come in fact, come.
You can come and reach here by 4:15. Then
Yeah.
you leave 7:15 or 20.
It's okay.
You know you can't cheat me.
Ready to be a triple.
But let's first see how the class becomes.
Yeah.
And then we agree when the whole class is there. You wait, they will be there trying to do like this, then all of a sudden they say, no, I want to do this course now. So, but for me, the fewer you are, the better.
The better.
I have reasons why I chose this course, but that doesn't make me want to hustle just because I had results. So, my attendance, please. So those who are fearing the Margaret, those who are fearing the collision and whatever, I've already explained that you can choose to be on a Wednesday, this side, then on a Monday, the other side, and vice versa.
About what? With the practical?
The practicals, and the other side, the foundations.